Hey, it's Ryan. Welcome to what I do in my free time. I'm gonna go over or attempt to go over the answers to this drill sheet. He posted a key. I just thought it might be helpful to watch in real time somebody work the problems, especially since not everybody is going to have a drill session before this test. So, anyway, number one says, which of the following does not correctly give the major product when the ester shown below is reacted with the reagent given? So this is the ester. I copied it for A, B, C, and D and then put the reagents respectively here. So A says the ester is reacted with lithium aluminum hydride in ether followed by an aqueous workup. And so the first, this is assuming an excess of lithium aluminum hydride, but the first time it would cleave this bond and open up the ring. The second time, it would finish off this carbonyl group and take it all the way down to an alcohol. And so the product is indeed what you would get. So B says the ester is reacted with two equivalents of this Grignard reagent right here in ether followed by an aqueous workup, and that Grignard reagent would in fact open up the ring, and it would add on two of these ethyl groups, which you can see is the alkyl part of this. I'm trying to underline it in green there, the alkyl part of that Grignard reagent. So that's where those two ethyl groups are coming from, and that again is the correct product. C says the ester is reacted with diol H and then an aqueous workup. And for C, I think he clarified this in the drill answer, but diol H at a low, or at like one equivalent and at a really low temp, would stop at the aldehyde. And so that is correct. As it's written, it's a little bit confusing, but he clarified that in his answer that he posted, that he's talking about one equivalent at a low temp, so you would get the aldehyde. If it was in excess and at high temps, it would also go down to the alcohol, but you're left with the aldehyde, one equivalent low temp. D says the ester is reacted with CH3, CH2Li followed by an aqueous workup. And for D, you're talking about two equivalents of that. And again, that is the product. And so the answer to this one is E. All of those products are formed. Let me scroll down here. We've got number two, and number two is a pretty curious question to me. But I'm gonna go through his answer rationale the way it made sense to me. So he said first that you'd start with benzene. I'm gonna switch back to yellow. He said you'd start with benzene, and you're going to add Br2 and FeBr3, and it's going to give you kind of that classic electrophilic addition product right there. And then you are going to react it in magnesium and ether, and that's going to give you the Grignard reagent version of this. So it's going to look like this. Now, in his explanation right there, I would kind of star that as stop. That's batch one. And so you're going to take some of batch one, and you're going to take some of this, maybe a couple equivalent, like you've got a beaker of this, we'll say, kind of a beaker of this stuff. That's batch one. You're going to take a little bit of this and put it in another beaker, And so that'll be your starting product, or your starting little compound. You've got MgBr, and you are gonna react it with CO2, followed by H3O plus just for your proton, and that is going to give you the carboxylic acid that he wrote in. Okay, and then you're gonna use SOCl2 to go from a carboxylic acid to your acyl chloride. And in this situation, it's kind of a pretty complex acyl chloride, but still it's an acyl chloride. And so that's what I would call batch 2. So we put a little bit of this in a second beaker, and right here, and I'll just show that it's kind of a different batch with a different color. So we've got batch 2 right there. Now I would take a little bit of this, a little bit of batch 1. No, actually you could just fill it up. So you can put a bunch of batch 1, an excess even of batch 1 into batch 2. And so essentially you're taking batch 2 that you started with. Now you've got that acyl chloride. That's what we'll start with. And you are adding that Grignard reagent to it. And you're adding it in excess, or I guess at least 2 equivalents of that Grignard reagent. And that's essentially going to add twice to that carbonyl carbon, and you're going to end up with that product that he showed. So I'll say times 2 there. So the way he wrote it, I don't think you can just, step by step through this. I think you need to reserve some of this. Like, you can't just go through it one time and end up at this product right here. I think you need to reserve a little bit in batch 1, and then take some of that and form that acyl chloride, and then you can dump that Grignard reagent that you started with back in there, and it will react once with it and form and it'll form kind of that like ketone structure, and then it'll react again, and you'll be left with the alcohol. And that H comes from the aqueous workup that you would have to do afterwards. When you do a Grignard reaction, you have to do it in ether, and so most of the time, in order to end up with that alcohol, because you'll be left with that O negative after the Grignard reagent, because it's an ether and there's not a proton, and so you have to follow it with an aqueous workup, so that you can take that O minus, add an H plus to it, and form OH, which is the alcohol. And let me just kind of erase this so I can show that you're ending with OH. So that's number 2. Kind of a tricky question. So here is number 3. It says your task is to actually I'm gonna show the question, and then I'm gonna scroll down for even more room. So let me read it really quick. Your task is to synthesize 2-phenol, 2-hexanol through a Grignard synthesis. Which pairs of compounds listed below would you choose as starting materials? And so the way I think you have to approach this, the way he approached it, is that you're ending with this product. This is what you want to synthesize, so how do you make it? So you can think about what bond you want to cleave. If you form one bond, you'll get a starting product, or if you cleave one bond, like we'll start with this one. You'll get, if you cleave that bond, you would start with these 2 different sides. So hopefully it'll make sense as I go along here, but you would start, or you would, yeah, let me get some papers. You would start with okay, so it took me a second to write that out. Sorry, but so you would start with this side, this like phenyl, the benzyl side or benzene side, and then you'd start with this side, which is your kind of hexane with the alcohol, your hexanol. And he's talking about a Grignard synthesis here. So basically, this is your Grignard reagent. You're saying that it would react with this hexanone, this six carbon chain ketone, and you're acting these two together to form this product. So I want to keep going. If you say you didn't cut that bond, and instead you decided to cut this bond and start with these two sides, that would have you starting with it would look like this number right here plus so you would start with this carbonyl group and then this Grignard reagent, and then let me scroll down here, and if you cut this bond right here, you would start with CH3 MgBr plus let me make sure I get the number of carbons right here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Okay, so you'd end with, or you'd start with this side over here plus that little carbon, that methyl. You'd make a one carbon Grignard reagent. And so the question asks, and you've got to know that what you would start with is the way the Grignard reagent works. What you would start with is just you take the magnesium out of there, and so you're kind of just taking the magnesium out of all of these. And you're saying that you would start with this benzene, this like bromobenzene. You're saying you would start with this alkyl bromide there, or this methyl bromide. And so the answer then, the one that shows up there, is C right here, and it is this one right here. It's A. So maybe just to clarify that, I'll circle in green. Okay, and I'll go down to number 4, but I'm gonna upload this in a different video just so the video is not like 45 minutes long. See you there.